Different atoms have different weights. For example, the weight of hydrogen is not the same as the weight of carbon, just as one would say that the weight of a stone is not as the same as the weight of a feather. The lightest element is hydrogen, whose weight is 1.67 times 10 power negative 24. This is actually a very small number if you actually write it in the usual form rather than the scientific form. However, one should know that these elements are dealt with on so many occasions during experiments. Their masses are too small to deal with. Take for example hydrogen and all the other elements which have similarly small weights. Another example given may be carbon, whose weight is 1.99 times 10 power negative 23. Scientists sat and agreed on a standard, that of measuring the weight of elements relative to the weight of a certain specific element. The certain specific element chosen first was oxygen, mainly because it was abundant in air and reacted with very many known substances. It was in such a way that the ratio of the mass of the element to that of a 16th of oxygen was obtained. The 16th was because of the mass number of oxygen 16 isotope, which has 8 protons and 8 neutrons, hence the mass number being 16. This was put into consideration due to the fact that protons and neutrons have a very close weight, though the weight of the neutrons was slightly higher. Oxygen was later abandoned as the standard due to its very many isotopes, that is, oxygen 16, oxygen 17, and oxygen 18. Hydrogen was then adopted as the standard due to the fact that it is the lightest of all elements. However, it was also abandoned due to its number of isotopes, which occupied an negligible percentage. Carbon was then adopted as the standard and still is. In most textbooks, carbon is referred to as carbon-12. This is because the most abundant isotope of carbon is carbon-12 and occupies 99% abundance. This means that ratios obtained using carbon-12 are very reliable, and for that matter, therefore, carbon may not change for a very long time. As the isotope is called carbon-12 due to its mass number 12, because carbon-12 has 6 neutrons and 6 mass. The value got after relating the atomic mass of an element to the mass of a 12th of carbon is known as relative atomic mass. The relative atomic mass of hydrogen is the actual mass of hydrogen, the ratio to a 12th the mass of carbon, which is actually the same as actual mass of hydrogen divided by a 12th of the mass of carbon, and that is how we get the relative atomic mass of hydrogen, which is 1.007, usually approximate. A very important note to make is that relative atomic mass has no units because it's a ratio, and this actually means that the units cancel out. From this explanation, therefore, the formula of the relative atomic mass of an element is therefore given as actual mass of an element divided by a 12th actual mass of carbon, and in some textbooks it's written as product of mass number of carbon-12 and the actual mass of an element divided by the actual mass of carbon. From this formula, it shows that the relative atomic mass of carbon is exactly 12.0. With this method, the relative atomic mass of all the 108 elements on the periodic table can be got. They are actually included on periodic tables. So now relative atomic mass has been explained and it should no longer confuse you in any way. This brings us to the end of this video. I hope it explained the concept awesomely and you are actually satisfied. Don't forget to like if you like this video, and make sure you hit the subscribe button below for more of the same awesome chemistry at heart.